Okay, now it's 50 student, 1 o'clock. Should we wait or we just start it? Start no? Nanti dia akan join eh. Okay. Ha. Tak apa. So ni last topic lah. Okay. Apa yang dia akan join lah. Sekejap saya nak on record lah. So kita akan buat OBE 1 Monday hari Isnin pukul 10 hingga 12 So saya dah forward dekat Penang punya group student. So mereka pun tak kata apa lagi tapi Monday tu memang okey lah. Monday tu adalah mereka punya robotik kelas. Ya. Recording dia berpusing-pusing masih belum start record. Okey. Okay. Okay, Assalamualaikum and good afternoon. Good evening lah, ke satu. Good day lah. Good day. Okay, today is your last chapter. So your last chapter, so your topic is robotic work cell. So this is also a last one of the examination question for this topic. So it's not difficult. Only you have to do a proper calculation. Don't do a careless mistake because this is not so difficult topic in robotic. It's not like kinematic topic. Okay. So robot work cell. So I have a video, 3 videos here. So I share the video. What is robot work cell? So this is one of the company, Motorman. So this what we call robot work cell. Example of robot work cell. So this is a welding process. So you see, in robot work cell, you have a robot, maybe one or maybe more. So you have a machine, maybe facility surrounding the robot. So operator also considered as one of robot work cell. For example, we count operator time. For example, maybe assembly something like this, we give 1 minute or 3 minutes operator to attach the equipment. So operator also become one of the robot work cell. So normally robot work cell, they have a cage surrounding the robot for safety. So cage might be mechanical, something like grill, or maybe you have sensor, so like laser or infrared sensor. For in this case, operator it's a little bit dangerous lah, because operator can enter during assembly process. But in this case, maybe operator required to confirm whether the welding is correct or not. So operator need to be enter in the process. So one case of this one set of robot and the accessory we call a robot work cell. So we have this is something like a jig for welding. So we have robot. We have a part here for replacing welding tip, welding head kan, or any factor we have in this area just now. So all this system we call a robot work cell. So in robot work cell, we will calculate a time that robot will be used to do a process, and the operator, maybe operator or maybe automation system to load product or to unload product. So we will count the time, load and unload. We will count the time for robot to do a job. Or maybe robot will do pick and place process, so we will count the robot time for pick and place process. So all this will be calculated to minimize delay time or idle time. Idle is not good for production. So idle that means machine or robot is do nothing, so just waiting. So that we call idle time. So I have another video. I have two videos here. So this is another video of robot work cell or welding process. So this is something like loader and unloader, or maybe jig. We call jig or pictures for welding. So we attach the product on part on this jig, so the robot will do a welding process. So you see, surrounding the robot, we have a cage or we have a wall surrounding the robot for safety. So, and this is also considered as a robot work cell because we like curtain, example here. So we have this is jig and this is robot, and we also have a sensor here or maybe a cage for safety. So one set of these we call robot work cell. This another example, robot work cell doing packaging or pick and place. One set of system we call robot work cell. Kena. So sini awak nampak kita we have a cage. So this one two robot in one robot work cell. So we have two robots. So this is packaging process. So we use a gripper or suction cup to do a packaging process. Palletizes 1,100 pallet totes with a custom designed spatula and a arm tool. However, this isn't the only type of tool this robot can use for picking boxes of products. So you have robot, you have maybe a machine or jig surrounding the robot. This is a conveyor, feeder. So this feeder as loading or unloading. This extremely versatile palletizing robot displays its flexibility. So in robot work cell, we will count what is the time the product load and the product out, the time used by robot, how many time that been used by robot. So all this will be parameter will be considered in the calculation in robot work cell. This system is able to palletize and stretch wrap 10 different SKUs and up to 25 loads per hour from 2 different lines. To learn more about FENIC authorized integrator, Kaufman Engineered Systems, please visit their website at kaufmanengsys.com. Okay. So this one we have learned in robot design, but we not in your subject we not focus a lot in robot design. We are focusing on kinematic, actuator, sensor, trajectory, planning, and robot work cell. Design maybe the location of robot under robot work cell design, but not design totally design the robot. Control, because we are we have learned in subject control, so we minimize this topic. So we do a control in a trajectory and path planning. Okay, in robot work cell, so one of the we can hear the name is something like flexible manufacturing system. This is one kind of robot work cell, but this is a famous name in multiple robot in one system. For example, this so a highly automated group technology machine cell machine to interconnection by the automation, material handling by and storage system, and controlled by integrated computer system. So this is a flexible manufacturing system. In this, or we call this also can be called a robot work cell. They are one cell of group of machine and robot inside. So flexible, capable to process a variety of different parts, style simultaneously at the various workstation, and the mix of part style and quantity of product can be adjusted in response to change demand pattern. So the FMS relies on principle of group technology. No manufacturing system can produce an unlimited range of product. Although he can do a lot of product, but it's unlimited. It's limited. It's limited. It's not totally can do what we call multiple product. It still have limitation. And FMS is capable to producing a single part family or limited range of part family. For example, the product have you do some product like handphone casing, for example. So you can change. You still doing the same family of product is handphone casing, but you can adjust your product little bit, maybe a different model, but still in the same family. Doesn't mean that a handphone then you can do maybe as a product, totally as a product lah, something like maybe glass or cup, something like that. So is the product is still in the same family lah, but you can change a little bit. This is the example system of flexible manufacturing system. Industrial training, you can see this a lot in the industry. We call FMS system, where in the FMS system you can see a lot of machine that be connected each other. This depend to the system lah. Some they use a conveyor belt, some maybe they use a robot to transfer. If you got an internship in Silterra wafer fabrication, so you can see the connection between machine will be transferred through a robot on the shielding. So you can see a lot of a robot like LRT or train located on the shielding. So all the wafer will be transferred like a lift going up to the shielding, and then there are a lot of robot like a train pick up the wafer and send to the next process. So they not carry on the floor, they carry on the shielding. So that is under wafer fabrication. They do that because they don't want to move the wafer on the floor, because they have if we move on the floor, we have a lot of vibration and we have a lot of stoppages. When we have a lot of stoppages, wafer is a silicon material, so wafer will shake. If wafer shake a lot, the particle will occur. Particle, that means because silicon is like a glass, it's brittle, so it can produce a dust, something like a dust. So that one is not is causing a reject for the product in wafer fabrication. So they carry the wafer using a robot located on the shielding side, the top side. If you get internship in car industry, so you will see a robot, a line of robot, banyak, so banyak robot in a line, parallel with the conveyor belt, So the robot will do a lot of tasks lah, something like painting, spot welding, arc welding, using MIT, TIG welding, and MIG welding. So the robot will be located along the conveyor belt. What is other company? In industrial or semiconductor, this is something like industrial or semiconductor. If you go in industrial semiconductor, you can see a lot of this type of FMS system. For example, if you internship in semiconductor, they have wire bonding machine that they put a gold wire or aluminium wire on semiconductor chip, or you can see a die attach process. They insert the chip on the PCB, but their system will be a straight line like this, and then your product will be transferred using a conveyor belt. So that one in semiconductor industry. So you can see a lot of this kind of system. So they have a lot of machine in a straight line position. So the process will be connected using a conveyor belt. For example, something like this. Maybe this is a wire die attach machine, and then wire bonding machine. Maybe you have oven to cure the product, and then you have something like this elevator. They call elevator or input and output loader lah. If you go in semiconductor product, they call this elevator. And then the product that you put in on this elevator, they call magazine. So magazine, something like and they put a magazine, a tray, something like a tray, but magazine because your product is built on the frame, so the frame will be slot into magazine. So you have input magazine and output magazine, and then your product will be sending piece by piece through a conveyor belt. So you can see a lot of this in industry when you go in intra next sem. Okay, this is the number of machine versus annual production and flexibility. So the highest annual production, flexibility and cost incur is a FMS system. So number of machine. So FMS, they have a lot of number of machine inside the system. So one system of FMS, so they have a lot of machine inside. So number of machine, so this one is biggest. The biggest one is FMS. So the single machine cell, single machine cell is what we are going to study now. So you have one robot or two robot. If you have more robot and more machine, so it's become FMS. If only one robot, so single machine cell, something like that. Robot work cell. Okay, now we go to robot work cell. Robot work cell, a robot and its associate equipment. Associate equipment is the equipment that surrounding the robot lah. So we have jig, we have welding, we call location, welding tip for changing the welding tip. So the location for changing welding tip, or maybe you have CNC machine. And then you have also lead machine surrounding the robot. So this definition of robot cell, a robot and its associated equipment form a basic robot cell. Okay. So sometimes human worker can also be included in the work cell to perform tasks that are not easily automated. So sometimes we need human. Human also become one of the work cell. Because sometimes the part need to be attached by the human. So we cannot do automated process. So that human will also be counted as a robot work cell. So we also count, maybe we set the time for the human to insert the product into the robot. We also count the time for loading. So we know that what the time that human use to load. This task may consist of inspection operation or operation that require judgment or a sense of touch that robot do not process. So that's why they use human. Okay. Two aspects arise in the robot application in industrial production line. One related to the design of robot work cell, which may consist of more than one robot and more than one machine. So machine is something like CNC, lead machine, for example, welding machine. That is others than robot lah. So robot is a manipulator, robotic arm. So robot, uh, one related to design of robot work cell, which is may consist more than one robot or more than one machine. So whether you have more robot or maybe you have more machine or maybe you have both more robot and more machine inside that work cell. So the other is related to control system that will be coordinate in the activities among various components of work cell. So one is related to design of work cell. Design, you have many type of designer. So you have a robot center work cell. Later I will explain that. Robot center, robot inline, robot mobile. So that one is a design of robot work cell. Control system, what is the control system that you will use to connect all these, to coordinate all these machine in robot work cell. So this is example of robot work cell with different company or brand. Example here, you have a cage, so you have a safety, a gate, and maybe you have sensor or you have a gate there. So this is loader and unloader maybe. So this is load, maybe this is unload. So this is raw material coming from here. And then robot do a process, maybe assembly or welding or pick and place here. And then after finish the product assembly, so you put your product for this on this unloader outlet lah. So you put here to move your product out, going out to the next process. So this is example of robot walk, Yashikawa, Fanak, Genesis, Kuka, ABB. So this is robot work cell. You can see inside, so we have robot arm inside the cell. So for example here you have 3 robot in one cell. This one got 1 robot in one cell. So this one maybe 1, this is 1, this is 1. So cells means that a lot of robot with the system inside one cage, one cell. So we call robot work cell. This is the layout or design of robot work cell. So there has 3 layout of robot work cell. One we call robot center work cell. So the main center, you later you know how to imagine center. Center, that's mean robot in the center. Inline, so inline robot work cell. So you can imagine already that the robot is inline, berderetan. Inline along the conveyor belt, for example. So you have many robot. You have many robot along the conveyor belt. So mobile robot work cell, that means mobile. Mobile, that means your robot can move. Robot can move, but it's not freely move. It move on the track. On the track. Normally move on the track. Okay. Here, robot is one of the design or layout is a robot centered work cell. So robot di tengah. So here robot is located approximately at the center of the cell and the equipment are arranged within the reach of robot. Reach mean that equipment is located surrounding the robot that robot can reach, can boleh capai lah kan. Can reach the part lah, or the machine. So part to be presented in known location and orientation by using of conveyor example. Okay, the robot service the equipment in particular sequence of its operation. Okay. This example of robot center work cell. So you can see that robot located around middle or center of the equipment. So this is your machine, machine, maybe G or maybe tool. Maybe this is your replacement of your end tool. Maybe here is your welding or drill or gripper. Maybe so this is one station. So and then this is machine, maybe CNC, and this one maybe a lead machine or maybe vision system to segregate within good and bad product. So all this is a station machine. So M minus 1. So you have more machine. One robot and multiple machine. And this is your loader input. So your input. And this is output. So a single robot is servicing one or more product machine. Okay. So this example layout of center robot work cell. Another example, this one, almost similar. So robot in the center, so you have machine 1, machine 2, machine 3. And this one, so you have machine 1, you have machine 2. And then this is the input buffer, output buffer, in and out. Loading, unloading. In, out, in the machine, some you can hear that they call loading, unloading. Okay, for example here, if you have different machine process, so for example this one do a screwing process, this one do a welding process. So that means your robot need to pick up the product and send to screwing process. After finish screw, then they send to welding process. So that means you have, if you not calculate properly, so you have a lot of idle time, delay time, idle. So for example, if your screwing process is 20 minutes and welding process is 10 minutes, so that means when your product go to the screwing process, so your machine 2 will be waiting for maybe 20 to 10 minutes. For first cycle, you need to wait for 20 minutes. Second cycle, maybe you need to wait for 10 minutes. So every product comes, so this machine number 2 need to wait for 10 minutes. So you have idle time. And then your robot also have idle time, because once your robot pick up the product, put in machine 1, so your robot need to wait for 20 minutes. So your robot also have idle time. So this system is not good. Unless if both machine running the same process, so when your product coming, so your robot will pick up and put at machine 1, and the second product comes, so robot will put in machine 2. So when machine 1 is finished, so your robot will send your product to the output buffer. And then pick up a new product, put in machine 1. So there are less idle time. Less idle time, but still not zero. Less idle time. So if you want to maximize your robot or to minimize your robot idle time, so that means you need to find out how to make sure your robot run without rest. For example, run without idle time. So maybe you have more machine here, or maybe you need to find other method to maybe based on your time, processing time here and processing time here should be shorter. Then your robot will have less idle time. That one we will define in robot work cell calculation. This is another example. So conveyor belt. So you take the product and then go to inspection, loading bay, pick up the product, put on loading bay, and then machine will do inspection. If the product is good and then send for, the robot will pick up and put in packing case. If the product is bad or rejected, so robot will put in reject box. So this is the output, this is input. Some application of this center work cell, so machining, loading and unloading, molding, casting, and etc. Okay, robot center work cell. The service operation are loading and unloading. The equipment with the partially finished product. Sometimes robot should wait or idle. Idle, that means robot should wait. Or machine wait. Waiting time. Or robot waiting time or machine waiting time. Till the processing by a machine is complete. For example, CNC machine or lead machine. The robot need to wait until the machine is processed is finished. So rugi So rugi. So ada time rugi. Parts are to be supplied to robot to perform a pick and place, loading and unloading or a processing operation, conveyor, part feeder, deliver, shoot, and pallet a mean of accomplishing the supply of part to the robot. This is how we feed the product or the part to the robot to the robot work cell. We call loading and unloading. Okay. Discrete part production such as die casting, machining, plastic molding and other similar product operation can be accomplished by this work cell. Okay. Okay. Now finish center robot work cell. So at least you have idea lah. If people say robot center work cell, so you can imagine that robot in the center. Machine is surrounding. Whether loading machine, unloading machine, or CNC machine, lead machine, inspection machine. So all that machine is surrounding the robot because robot located on the center. If we say inline robot work cell, so inlines mean line. A lines of robot. So berderetan. A line of robot. Robot is located along a moving conveyor and to perform tasks on the product that is coming on the conveyor. Okay, so you have robot, more than one robot because line robot. And then along the conveyor. So this one you can see on the car industry production. Many inline robot work cell involve more than one robot. So there are more lah sebab dia sebut line kan, inline. Sebaris. Berbaris.
Yang robot dalam lab tu inline juga kan?
Dalam lab ni yang mana? Yang kecil ke yang besar?
Yang besar belakang doktor.
Kalau yang besar ni dia panggil kalau dia satu, okey. Kalau ikut dalam satu set tu kita panggil robot work cell. Robot work cell tapi dia bukan center, dia inline lah. Betul lah, inline lah. Sebab dia berada di tepi conveyor belt. Inline.
Okey.
So cuma conveyor belt dia bentuk bulat lah. So bulat ini straight line kan. Sama lah. So dia ada macam belakang saya ni ada vision system, ada robot 2 biji. Cuma conveyor dia bentuk bulat. Sebenarnya dia straight line juga lah, sama lah. Okay. So yang contohnya macam ni. So inline dia ada pecah. So inline dia also has been split into several type of inline lah. So this is one example lah. So we have two robot and then inline robot is along the conveyor belt lah. Along the conveyor belt. So this is work part, this is conveyor that carrying the part, and then this is robot. So this we call inline lah. In our lab, although their conveyor belt is circle shape, but it's still considered as inline lah. One common example is car body assembly, industrial atau industrial automation industrial, car industrial, automatic industrial. Robot are positioned along the assembly line to spot welding, car body frame and panel, for example lah. So nak welding or painting, so the car body will be transfer through conveyor belt, and then robot will stay along the conveyor belt to do the task. So inline we divided into three lah: intermittent transfer, continuous transfer dengan non-synchronous transfer. So three category of transfer system. So intermittent, you can imagine already. Intermittent, that mean stop. Intermittent lah. Continuous, that mean your product and your robot will be continuous on the conveyor belt. So it's non-stop. Then non-synchronous, we will see later how is non-synchronous transfer. Okay, synchronous. Synchronous or intermittent transfer system. So the part, move the part with start and stop motion. Start, stop. So when the product come to the robot, stop. Stop, then robot do a process until finish, then put back on the conveyor, or maybe conveyor stop, or robot pick up the part, put on the front of the robot, and the robot do a process. And then when the robot finish, do the process and then put back on the conveyor. So this is intermittent. Okay, motion from one workstation along this line to another workstation. Okay, here all parts are moved simultaneously and then registered at the next respective location, and the robot are stationary along the line of transfer. So robot stationary, dia duduk di tepi conveyor tu. Advantage, a part is registered and keep stationary so that robot finish the process during the robot work cycle. So dia ambil part tu, dia letak dekat robot tu, dia buat proses. So siap dia letak balik. But this one is not good for manager, because the product is, the output is difficult to target the output quantity lah. If continuous transfer system, so your boss will be easy to predict your output lah. How many thousand unit per day. So because your processing is continuous, your transfer system is continuous. But this one, so every process, so your product will be removed from the conveyor and then put on the robot. Robot do a process. So your time is not, process time is not good lah. Okay, continuous transfer system. Okay. So you see continuous transfer system. Continuous transfer system. Here the part are moved continuously along the line at constant speed. So your product will move continuously through the conveyor belt. This means that the position and sometimes orientation of the part is continuously changing. So this improves productivity. The problem is for the robot to have sufficient time for working on the part. This problem is solved by the robot with moving baseline tracking, stationary baseline tracking. So we need to put a vision system or maybe sensor. Okay, moving, I will show the figure later. Moving baseline tracking, moving the base of the robot along the conveyor to some calculated distance. So your robot can move. Require a cut wheel on which the robot is to mounted. Create extra degree of freedom for the robot. Due to this solution, sufficient time is available for a robot to do a job or task on the part coming along the production line. The problem of possible collision between neighboring robots to be taken because your arm will be extended. So this process is complicated lah because your product will move along the conveyor and then your robotic arm need to manipulate to do the task, manipulate while your product is moving. So your product is moving, then your robot will be manipulate, do the task in the same speed of your product moving on the conveyor. If the robot are placed at sufficient distance for collision-free operation, additional floor space is required. The time of production is also increased due to the part are to travel additional distance. Sensor-based artificial intelligence control can avoid robot collision as a robot know where exactly the other robot is extending its arm. So if you do like that, so your robot, the neighbor robot also raise their hand, their arm to do the process along the conveyor. So the next robot also do the same task. So collision will be occur lah if we not put a sensor or vision system, so the robot will crash each other. This example of stationary baseline tracking system, for example, robot is located in a stationary position. So robot is here. Create a tracking window. So this is your conveyor belt. So this is tracking window. Tracking window will be using vision system or maybe you have sensor here to detect your product coming in. So when your product detected by the sensor, then your arm, your robotic arm will start do a process. Maybe screwing or maybe welding. So your product will move along this tracking window. So robot must be programmed sufficient enough time before your product exit this window. So that means when your product enter this window, so your robot start do a process until your product, your robot will stop when your product going to exit the window. So that means when your product exit the window, that means the process is finished. So when the part enter the tracking window, the robot start to work on the part, must complete its work before the part leave the window. So that means your robot will start do a process from starting window here until your product going to exit. So your process is complete. So that means your robot must play around with your manipulator. So it's a complex programming task lah. The easier way, you pick up the part and put in the front of the robot, and then robot will do the assembly process. But that process we call intermittent lah, because you need to move your part outside from the conveyor. After complete, then put back on the conveyor. That one is intermittent. This is continuous because your robot need to follow the speed of the conveyor. The tracking window is the intersection of work volume of robot with the production line. Sensing, presenting of part within the tracking window is required. Sensing, so required maybe camera or maybe sensor. Robot start its function as the part enter the tracking window. So robot start do the task when the part enter the tracking window. Problem of stationary baseline tracking system. So that one, stationary baseline tracking system, dia punya problem, robot has to continuously manipulate its joint so that it does the required job on the part without interruption as the part is moving on the conveyor. So the manipulated robot must be continuous manipulate the arm lah. So dia kena manipulate dia punya arm tu. Real-time controlling of robot has to be very effective. So robot processing time must be very good, very fast, so that he can do a manipulation in the same speed of conveyor. So the velocity of part coming along the line, velocity has to be known and fixed. So that means conveyor belt velocity must be known, must be fixed velocity, cannot be suddenly fast, suddenly slow, because a robot must manipulate based on the speed of conveyor. So variation in velocity will deter effective robot cell performance. So the important thing, this type of baseline tracking system is quite complicated lah. So robot and conveyor must be synchronized. Okay, non-synchronous transfer system, also known as power and free system. Each part moves independently along the conveyor in the stop and go fashion. Each part is placed on a cart that moves along the conveyor at the workstation. The cart is brought away from the conveyor near to the robot so that robot can take its time for performing a task on the work part. So dia tarik keluar, remove the part and then do a process. Complex and it's to be provided with sensor to decide where exactly the cart is. Sometimes the conveyor may be stopped so that the duration of robot task on the part is substantially long. So yang ni, this one difficult to manage the output lah. So because it's sometimes the conveyor need to stop. If they design the inline robot work cell like that, non-synchronous, that means conveyor need to be stopped and then wait until the robot finish the process and then put back on the conveyor. So that one lost a lot of time lah. Robot is capable of moving the various equipment within a cell. A mobile base is needed. This could be accomplished by having rail either on the floor or overhead so that the robot can reach the equipment easily. So this is mobile. This is mobile robot work cell. Robot is capable of the moving of various equipment within cell. A mobile base is needed. That means robot can move left and right, maybe. This could be accomplished by having a rail either on the floor or overhead so that the robot can reach equipment easily. So this is rail lah. So robot located on the rail, so robot can move left and right. For example, if this machine do a same task, so a robot can pick up this buffer, this input part. Robot can move left and right, so he can pick up this part, put in the machine. And when the second part coming, so robot can pick up second part and put on machine 2. So if machine 1 finish, so robot can pick up product on machine 1, put on the output buffer. And then put another new product on machine 1. So we can see that their time is fully, something like fully utilized lah. Fully utilized. So this example of overhead system lah, mobile robot. Overhead system is expensive, but reduce floor space. And then another very effective but complex design is to have more than one robot operating in one network, in a network of real system overhead. This can effectively reduce the machine interference and robot idle time. So what is machine interference? What is robot idle time? Machine interference is machine waiting. Same like idle. So robot idle is robot waiting. Later I will explain what is machine interference and what is the idle time. So this is overhead rail system. So they put a robot in the rail, so robot can move left and right. So this is floor track system. So the track on the ground, on the floor. So robot can move left and right along the conveyor. Okay. So multiple robot and machine interference. Okay, now we go for calculation. Okay, how many slides? So 34. So we left about 10 is 44. 44 plus 7, 17 slide. But it's not more. Just a little bit. We go for calculation. Physical interference of robot. Okay. The work volume of robot in the cell are overlapping, posing danger of collision, separating the robot so that their work volume are not overlapping. In some cases, multiple robots are working on the same workpiece, so the program work cycle of the robot must be coordinated not to be near to the risk of collision. This is about collision. Okay, machine interference. What is machine interference? This occurs when two or more machines are being serviced by a robot. So if you have more machine, more than one, this one is two or more. So if machine have waiting time or idle time, so that we call machine interference. So the machine cycle are timed in such a way that idle time is experienced by one or more machine, while one machine is being serviced by the robot. So maksudnya, if robot service or do pick and place at the machine A, so machine B is waiting. So when machine B is waiting, so we have idle time. So that idle time for machine we call machine interference. Machine interference can be measured as total idle time of all machine. So machine A got idle time waiting for the robot. With machine B also got idle time because waiting for the robot service. So total all the machine idle time we call machine interference. So the measure is commonly expressed in percentage. The value of machine interference is in percentage. Okay, this is example. So we start calculation. Okay, untuk definition in your examination, I hope it's not difficult lah. Because this is open book exam, so I hope this is not difficult. Maybe they ask about design of layout machine, machine layout, about that. So this is theoretical lah. So it's easier in OBE examination lah. So only for the calculation is different lah, based on your each of the student. So the question will be different little bit. Okay, a robot is working in robot center work cell. That means you can now you can capture that robot center work cell. That means robot in the center. Servicing 3 machine. So service 3 machine. That means robot, the function is pick and place. So he pick up the part, put on machine 1, put on machine 2, and put in machine 3. So that the task of the robot. So the cycle time of each machine is divided into service time 20 seconds, and run time is 30 seconds. Find the machine interference. Assume the part are automatically unloaded from machine. So assume that part are automatically unloaded. So that means we not consider the time for unloading process. So we not consider time for unloading process. So tak ada lah. Masa unload tu tak ada. So kita cuma ada proses loading je lah. Loading, that means service time by the robot lah. So 20 second each machine. So that means robot will pick up the part and put machine 1 in 20 seconds. And then take another part, put in machine 2 in 20 seconds. The process of pick and place take 20 seconds. And run time of machine is 30 seconds. So run time for each machine is 30 seconds. So how we draw this robot machine process chart? So this example. But for me, this example is quite easy to make a mistake because this example, for example, you divided the scale 1 to 20 because you're going to put this service time 20 seconds by the robot kan. So they divide by 20. For me, I prefer to divide by 10. If you have this kind of problem, so better divide by 10. So you have a small scale. So you don't have this kind of line. This kind of line. So 1.5. So it's difficult to calculate. Sometimes it's difficult to calculate. So better you have smaller scale, 1 to 10, 10 to 20, 20 to 30, 30 to 40. So at least you have another line in between. So you know that one line is equal to 10. So it's easier for you to calculate. Okay, how the robot load? So this is robot service. Load 1 means that you load, your robot load into machine 1. Load means that your robot pick up the part and put to the machine. So load. So you put 1 here because you going to prevent a careless mistake to make sure that this load into machine 1. So this is machine 1, machine 2, machine 3. So first robot load product to machine 1. Robot takes 20 seconds. 20 seconds. So 20 seconds. Then you see this one for the first cycle, this one is not complete. So this example is a second cycle. Actually, it's a second cycle because you already know this is idle, this is run. But if you draw a robot machine process chart, suppose this is empty because you didn't know what is the process here. So you know that the first cycle load, and then after finish 20 second load, then your robot can service or load into machine 2, 20 second. After finish loading machine 2, your robot will load machine 3. So takes 20 seconds. So all the above here is still unknown. Actually, it's still unknown. This one is still unknown because this is starting. So you know that you only know machine 1 load here, machine 2 load here, machine 3 load here. Okay, after loading, then your machine start running. So running for 30 seconds. So 30 seconds, do 1 box and half. This one is difficult. If you divide your scale into 10, so it's easier lah. You have extra line in between. So this is 30 seconds. And then your machine 2 after load, then run for 30 seconds. Machine 3 after load, you run for 50 seconds. So after finish, after you run your robot, okay. After your robot load machine number 3, here, so you can load machine number 1. So because your robot will be continuous, load machine 1, machine 2, machine 3, and then load again. Machine 1, machine 2, machine 3. So you only can load machine 1 cycle, go back to the first cycle, after finish loading machine number 3. So you see this line? So after finish machine 3, then you can start loading machine 1 back. So load, run, idle. Okay. And then after loading machine number 1, finish. So you can load machine number 2. After finish machine number 2 loading, you can load machine number 3. So you see that diagonal line, diagonal line. After you do this robot machine process chart, now you can find your idle time. So you can see here you have idle time 10 seconds, 10 seconds, but you need to take one cycle. One cycle that means between 60 to 120. This is one cycle. So the second cycle now is complete. So every slot here already defined, whether it's loading, run, or idle. So now it's complete. The first cycle is not complete. You cannot use the first cycle chart to calculate because this column or this section is not complete yet. You didn't know whether it's run or idle. So second cycle is complete. So you see from 60 to 120. So you know that you have this idle time is 10 seconds. This is 10 seconds. And this is 10 seconds. So you have idle time. Total idle time for machine is 10 seconds. Do you have any idle time for robot? No, you don't have. Because you don't have any gap between a robot. So your robot is fully utilized. Load, load, load. And then after loading, finish loading, you start loading again. Load machine 1, machine 2, machine 3. And then start loading again. So you don't have idle time for the robot. So your robot is fully utilized. But you have idle time for your machine because your machine need to wait. Here is 10 seconds. This is 10 seconds and this is 10 seconds. So you have 30 seconds waiting. So your machine cycle time 60 to 120 is 60 seconds. So we go for the calculation. So this is definition. What is loading, what is idle. So what is running, robot cycle time, machine cycle time, machine interference, this definition. So the total robot cycle time is 60 seconds. So idle time all machine is 30 seconds. So 30 seconds divided by 60 seconds, your robot cycle time. So you have 50%. So you have 50% machine interference. So your idle time, each machine is 10 seconds, so total is 30. So your machine interference is 50%. This means that the robot work cell is unproductive for 50% of a robot cycle time. So in one robot cycle time, your machine doesn't work for 50%. In general, if robot cycle time, another mean, if robot cycle time is bigger than machine cycle time, machine interference occur. Machine will be idle. That means if your robot cycle time is 60, and then your machine cycle time is 30 seconds, so you have idle time. So idle time there is 50%. For example, in this case, 50%. If your cycle time of robot and machine is equal, then you don't have machine interference. That means machine is fully utilized, robot also is fully utilized. Okay, untuk calculation ni penting. So mesti kena faham. Faham tak setakat ni? So daripada soalan ni, kita develop robot machine process chart. So kalau boleh buat skill dia yang paling sesuai lah. Kecil lah. Paling sesuai supaya kita tak jadi macam ni lah. Line sekerat-sekerat macam ni. So mudah careless lah. So make sure you ada line setiap ni. So nanti saya tunjuk cara lagi mudah. Setakat ni faham lagi? Baik, sunyi je.
Okey kot.
Okey.
Okey kot. Okey. So, harap-harap faham lah. So ni first example lah. Ada 2-3 example lagi. Okey, maksud dia robot cycle time 60 second. Kalau mesin ada 3 biji, setiap mesin ada idle time 10 second. So total dia jadi 30. Okey, untuk cari mesin interference, so kita totalkan 30 second bahagi dengan 60 second robot punya cycle time. So kita dapat 50% mesin interference. So kalau kita sebaiknya kosong lah. Yang terbaik adalah kosong, tapi susah lah nak dapat 0%. Melainkan awak betul-betul calculate ataupun program mesin tu supaya dia punya masa tu sama dengan machine cycle time, robot cycle time. So dia akan hilang. Ataupun satu cara lagi adalah awak lajukan mesin, awak lajukan proses robot servis tu. Setiap mesin dia hantar 20 second setiap robot. So make sure you program the robot so that robot send to the machine 10 second. If you send 10 second, service the machine, so send the product to machine in 10 second each robot. So your total cycle time is 30. So 30 divide 30 is 0, 1 lah. Okay, robot cycle time bigger, machine cycle time. Machine have occur, machine interference occur. Ni example lah. So develop machine, robot machine process chart. Develop a robot machine process chart. Prepare the process chart at least 3 cycles. Determine machine interference. Determine robot idle time. Machine interference ni adalah jumlah total of machine idle time. So total of machine idle time we call divide by robot cycle time, we get machine interference, the value in percentage. Robot idle time in second lah. Okay, for example, load machine 1, machine 2, machine 3. Robot load or service lah. Load the part to machine 1 takes 20 seconds. Robot load into machine 2, load the part to machine 2 takes 10 seconds. Then robot load into machine 3 takes 5 seconds. Machine run 20 seconds. Each machine run 20 seconds. Develop your machine chart. So this is because you do open book exam, So the easiest way to count this is you can use Excel. If you can use Excel, so you can calculate this quite accurate lah. So your drawing also very nice, and also you going to calculate also is quite it's good lah, better than you draw by your hand. Because when you draw by your hand, so to make a mistake is very high lah. So I see for first cycle, this is first cycle. This is the first cycle condition lah. Because you didn't know yet what is this. For example, here yellow is robot. We call robot service. Put in place. Service. Put the part to machine 1. The green color is machine running time. This is robot service loading time. Robot loading time. The green color is machine running time. This is machine running time. This is robot loading time. So second cycle, so this is a complete robot cycle lah. From this start, robot start and then start again. So this is one cycle. So how you know that robot cycle? So you need to see robot start here, loading. And then you start loading for the second cycle. So time from here to here or here to here is robot cycle time. Robot cycle time. Now you can see robot also have idle. So this is not good. Not good program lah. It's not good program or arrangement. So your robot need to wait also. So first is you set robot service 20 seconds and then machine running 20 seconds. So you put here robot loading 20 seconds and then machine 2 robot loading in 20 seconds. 5, 10, 10, 20, 10 seconds. Then robot loading at machine 3, 5 seconds. Then you know that machine running, each machine run is 20 seconds. So you put different color. So this is running, machine running, machine running, and machine running. Okay. Okay, I'm going to ask class if you understand here. Why robot run at 45 seconds? Why robot run at this time 45 seconds? Why robot not run at 40 seconds? Because this is finish loading process. Your robot finish loading machine 3 at this 35 second 35. So why robot cannot load at this 40 seconds? Why robot need to load at 45 seconds? Anybody can give the idea or not?
Machine
Why?
one not finished.
Yes, correct. Because your machine 1 run for 20 seconds. So robot need to wait machine 1 finish. After 20 seconds here. And then robot can start loading back machine 1. So that's why robot need to wait here. You see all green color here. Because currently all 3 machine is running. So when machine 1 finish the process, robot can start loading back machine 1. So we can see from this chart, robot idle about 5 seconds here. So the green color here. So you can see at cycle number 2, but we call cycle 1 lah. This is complete cycle 1, but actually cycle 1 is not complete. So this is we call cycle 1 because the data, everything is complete. So we know that, this is cycle 1. Then we can put back the green color here. So we know that after 20 seconds. So machine 2 need to wait for the robot service. Machine 3 need to wait 15 seconds for robot service before he start loading a new part to machine number 3 and before robot loading part to machine number 2. So we have this total number of idle for machine 2 and machine 3. Machine 1 is okay, no idle time, but machine 2 you have 25 second idle time. And then you also found that from this chart, robot also have idle time because robot need to wait for 5 seconds until machine 1 finish the process. Now you can find your cycle time. You know already, here is 40, robot cycle time. And then you want to find machine idle time. So you know that machine idle time is 25. Robot idle time, idle time is 5 seconds. How to find machine interference? So machine interference is total number of machine idle is 25 divided by 40. Idle time in percentage, or this is we call machine interference. This is machine interference. Okay. Salah jam. Interference. Oh, E. Okay. Then you get the answer here lah. This one robot interference lah. This is machine interference, this is robot interference. In percentage. So as engineer, so you need to find the solution how to minimize this. So to minimize this, there are many steps lah. Once there are many methods lah to minimize this. Once if you can run this machine if you prolong the process time, actually you are minimize idle time, but you are not solving the problem. Or the other way, you can minimize this by improving or increase the speed of machine 1. So when you increase the speed of machine 1, so your process of machine 1 will be shorter. When your process will be shorter, so you can minimize, you increase the speed of machine 1 from what is this? From 20 seconds to 10 seconds, to 15 seconds, then you can start loading back your robot here. So when you start loading back your robot here, so you can minimize your robot idle time. So when your loading is here, that means you can loading machine 2 little bit upper, so you can minimize your idle time in machine 2. Same go to machine 3. So how to minimize this? So you need to improve your machine 2 processing speed. Minimize another 5 seconds. So when you minimize another 5 seconds, so your idle is totally gone. So you don't have any idle here. And then you need to minimize or increase your machine 3 speed another 5 seconds. So you totally eliminate all this idle. So when you eliminate all this idle, so your idle time equal to 0. Machine idle time go to 0. So 0 divided by 40 is 0. 0 multiplied by 100 is 0. So you have 0% of machine interference. You don't prolong. If you prolong your machine running time, you can eliminate idle. But actually you cheat your manager. So your manager said, how to eliminate this idle time? You make your machine tool slower. So you make your machine tool slower for 10 seconds. So you eliminate the idle. And then you slower your machine 3 for 15 seconds. So you eliminate your idle. But actually your production stay maintained slower. Although you slower your machine, your manager said, you said to me, your manager, okay, we already eliminate machine idle time, but production is not improved. Because why? Because you prolong or slower your machine. Slower your machine, so you eliminate your idle time. Actually, you not slower the machine. You need to increase your machine speed. 1, increase your machine speed. 2, for 10 seconds. Improve your machine number 3 for 15 seconds. Increase your speed. So then you eliminate your idle time. So your system is fully utilized. Your robot also have no idle time, and your machine also doesn't have idle time. So this is how process engineer work to eliminate idle time, to make it your production fully utilized. Okay tak? Faham tak? Kalau dalam bahasa macam ni lah. Okay, robot ada berhenti. Robot berhenti kan. So berhenti 5 saat. So macam mana kita tak mau bagi berhenti? Kita lajukan mesin nombor 1. Daripada 20 second kita kurangkan jadi 15 second je proses dia. So awak punya loading time boleh start dekat sini lah. So robot boleh start kat sini lah loading time. So bila start kat sini, apa jadi? So bila start kat sini, so awak punya idle time ni hilang lah. Idle time ni hilang. Untuk yang robot lah. Hilang. Sebab awak tak ada delay kat sini. Awak tak ada idle kat sini. So automatic hilang. So cara dia lajukan proses mesin 1. So bila dia naik satu step, so yang ni akan naik satu step. Loading akan masuk lebih awal. So masuk lebih awal, so tinggal delay ataupun idle 5 second. So macam mana nak eliminate delay 5 second ni pula? Dengan cara lajukan pula mesin nombor 2 ni. Lajukan mesin nombor 2 ni 5 second. Bila laju 5 second, delay awak akan hilang. Idle awak akan hilang. So loading pun akan naik satu step lah. Dia naik satu step. Naik 2 step. So dia akan hilang. Dia naik ke atas ni kan. Okay, yang ni dah naik ke atas satu step, tinggal 10 second kan. 10 second. 10 second yang ni start loading kat sini. Dia nak step loading kat sini, 2 kat sini. So sini loading kat sini. So yang ni pun akan kena lajukan. Lajukan mesin nombor 3. So dia punya loading pun naik ke atas. So dia akan eliminate idle time yang 10 dengan 15 ni. So dia akan hilang. Hilanglah idle time kat sini. Dah hilanglah idle time kat sini. So cara dia dengan lajukan mesin awak. Bukan perlahankan mesin. Dia ada dua cara. Lajukan, so you dapat higher production. Kalau awak nak eliminate perlahankan mesin, Boleh juga eliminate idle dengan perlahankan mesin. So perlahankan mesin daripada 20 second jadikan 60 second. Bagi slow robot awak tu. Slow mesin awak tu. Oh, dia hilang lah, eliminate lah. Tapi production sama. So yang ni awak perlahankan tambah lagi 15 second. Perlahankan mesin awak bagi slow. So hilang lah merah ni. Tapi output awak sama je. Tak laju pun. Itu cara solution dia lah. Tapi kalau perlahankan mesin ni bukan solution lah. Itu untuk tak bagi bos marah. Nak bagi hilang ke idle je. Ada yang faham? Tak faham tak? Kalau faham, boleh faham tak? Tapi selagi awak tak buat, kita panggil robot machine process chart ni, if you didn't draw this, plot this robot machine cycle chart, you cannot define your idle. You cannot define your idle because your idle time will be defined after you draw your robot machine cycle time. After you draw this, you plot this, so now you can define, oh, you have idle time here. Oh, you have idle time at your robot. Actually, your robot also stop for 5 seconds. So machine 2 stop for 10 seconds. Machine 3 stop for 15 seconds. This you found after you plot this machine, robot machine cycle time ni process chart, sorry. Robot machine process chart. If you didn't plot this, you didn't know where is your idle time. Tuh, sekarang dah. Boleh tak Nek? Boleh tak? Boleh jawab soalan nak macam ni?
Ni masuk next week punya exam ni lah?
Oh, mestilah ni OBE2.
Aduh, macam lah.
OBE2. Machine robot work cell lah, satu topik lah. So robot work cell, one question lah in your OBE2. Senang saja. Guna Excel. If you can use Excel, you draw a proper draw lah.
Tak apa, pergi jumpa doktor lah. Pelajar doktor, boleh doktor.
Ni example dah ada dah. Example dah ada. So, lebih kurang macam ni lah dia punya problem situation lah. Untuk robot work cell, situation problem dia macam ni lah. So you kena draw dia punya robot process chart ni. Robot process chart ni. Robot machine process chart. Then you boleh define dia punya idle time. Kalau awak tak draw, tapi draw mula macam ni. Draw mula macam ni. Loading, run, loading. After loading ni, start loading mesin 2, run. Run tak tahu lah berapa minit kan. Berapa saat. Kemudian, selepas loading mesin 2, loading mesin 3. Lepas tu run lah ikut kita punya mesinnya running time tu. Kita pun tak tahu bila dia nak ada idea kan. Kemudian bila kita dah habis run mesin nombor 2, kita start loading balik. Start loading balik, sambung di bawah ni. Lepas tu run balik selama berapa second oleh mesin 2. Bila dah start loading mesin 2 ni, mesin 1 ni, dah habis loading mesin nombor 2. Habis mesin nombor 2, loading mesin nombor 3. Senang je. So dia punya sequence tu mesti cantik lah. Loading pertama, habis. Loading kedua, habis. Loading ketiga. Lepas tu letakkan running time machine. Letak running time machine, letak running time machine 2, letak running time machine 3. Lepas tu, bila dah habis machine 2, machine 1 running, start loading balik. Robot start loading balik. Bila kita dah plot macam ni, baru kita boleh jumpa, oh robot ada kita jumpa di antara running time machine 2 dengan loading balik, ada satu ruang kosong. Ruang kosong ni adalah idle time dia lah. Kemudian lepas mesin 3 jalan, kita loading di sini. Oh, kita jumpa ada gap antara running mesin 3 dengan loading mesin 3 ada gap. Gap tu lah idle. Idle. So kita boleh color line kalau guna Excel cantik lah. So kita boleh differentiate color. Kita boleh differentiate color. So kita boleh bilang lah kotak ni. Oh ni 5, 10. Oh 10 second. Ni 5, 10, 15. So 15 second. So idle 15 second. Tiba-tiba kat sini pun ada idle pula robot ni kan. So robot idle 5 second. Boleh kira semua lah. So boleh dapatkan semua value ni. Ada apa soalan tak dengan contoh macam ni?
Doctor.
Ya.
Meaning the idle time we determine ourselves, Doctor. The
Yang mana,
robot
yang
idle time. The idle time, the 5 seconds.
Robot idle time.
Yeah, we determine ourselves.
Oh, bukan. 5 second robot idle time ni dia akan muncul. Bila awak plot graf ni, chart ni, nanti dia akan awak boleh detect sendiri. Oh, dia ada idle time. Kalau tak ada, memang tak ada lah. Kalau katalah saya buat contohnya, mesin 1 ni jalan 15 second. 15 kan? Kalau saya buat 15 second, 10, 5, 10, 15. So dia akan start loading di sini kan? So bila start loading di sini, tak ada lah. So mesin idle time tak ada. Tapi sebabkan saya letak kat sini 20 second. So bila 20 second mesin running time untuk mesin 1. So baru dia start loading balik, robot loading balik mesin 1 kat sini. So memang nanti bila kita plot kita boleh nampak, oh kat sini robot idle. Robot tak ada kerja, dia duduk lepak aja. So kita boleh jumpa kat sini. Selepas kita plot graf baru kita boleh nampak, oh robot ada idle. So untuk kalau saya buat soalan ke apa pun, saya pun tak tahu di mana idle dia tu. Melainkan plot graf. Bila plot chart, bila kita plot chart pun kita nampak, oh dia duduk kat mana. Tapi sikun kena cantik lah, sikun kena betul lah. So lepas load mesin pertama, robot akan load mesin kedua. Lepas load mesin kedua, robot akan load mesin ketiga. Kemudian awak plug in mesin running time. Plug in mesin running time, plug in mesin running time, plug in mesin running time. Kemudian awak kena pilih di mana bila masuk mesin running time ni, habis dia running time, so start loading balik kan. Start loading balik. Start loading. Di sini baru awak tahu, oh di sini ada idle untuk robot ni 5 second. Kemudian baru awak jumpa mesin 2 punya idle, mesin 3 punya idle. Clear tak?
Clear, Doctor. Thank you.
Okay. Ada lagi soalan? Penting ni. Tapi ni antara soalan selalunya robot Watson ni student score lah. Student score. Make sure faham lah. Make sure faham dia punya cara draw, how to draw dia punya chart. If you draw properly dia punya chart, then you can get the correct answer lah. Setengah tu dia draw tapi dia tak faham. Ni robot, ni mesin, kadang dia buat dia punya timing ni, saya jumpa pelik-pelik lah dia jawab dalam exam kan. Sepatutnya loading lah, loading mesin 1, loading mesin kedua, loading mesin ketiga. Senang je. Robot loading, kerja dia loading lah. Loading mesin pertama, loading mesin kedua, loading mesin ketiga. Lepas tu dia beritahu mesin run 20 second. Hash lah dia punya 20 second. Awak letak, kalau dalam lukisan tangan awak draw kan. Awak buat palang. Mesin 3 pun palang 20 second. Kemudian start balik loading. Start balik loading pertama, habis loading kedua, habis loading ketiga. Di mana ada gap tu, di situ adalah idle time lah. Kalau awak buat cycle kedua, ketiga, awak akan dapat pattern yang sama lah. Pattern ni sama je untuk cycle kedua, cycle ketiga, cycle keempat sama. Cycle pertama ni saja dia sebab dia tak complete. So awak tak tahu lagi sini apa dia. Sini awak tak tahu lagi apa dia. Bila awak buat cycle yang kedua ni, baru awak nampak gap ni adalah gap idle. Okay. Awak try lah buat.
Faham.
Try buat tengok. Lepas buat baru awak boleh clear. Ni example satu lagi. Sama je. Ni robot. Ni mesin satu, ni mesin dua. So, kita letak nama loading one. Loading one ni maksud dia robot tu loading mesin satu. Loading tu maksud dia robot tu loading mesin dua. Ini dia buat mesin satu warna hijau. Mesin dua warna biru. Guna Excel senang. Guna Excel senang je. Kelebihan awak lah guna OBE ni, so awak boleh guna Excel. So letak color, tak confuse lah. Lepas tu mesin run warna putih. So mesin run warna putih, run 20 second. 20. Kemudian mesin tu pun run 20 second. Ini ada unloading pula. So dia robot tu ambil, letak, lepas tu dia ambil balik. So unload dia 30 second. Ini unload mesin satu. Kemudian unload mesin 2 20 second. Habis loading. Lepas tu run, mesin tu run. Ni cycle pertama jangan kira lagi. Okay. Sebab dia tak complete gini. Ambil cycle kedua. Lepas tu lepas run. Dia tunggu habis robot loading mesin pertama. Baru dia boleh unload mesin kedua. Yang warna biru ni kan unload mesin kedua. So, and then dia load balik mesin pertama. Load balik mesin pertama. So, yang ni dia ambil daripada sini ke sini. Sebab ni baru boleh juga macam ni. So, dia ambil daripada sini ke sini. Loading pertama, dia ambil yang di bawah loading pertama ni. Ni pun satu cycle juga. Boleh juga. Ataupun awak ambil start pada satu cycle ni sampai sebelum loading pula. Boleh juga. Loading pertama, sampai nak jumpa loading pertama, satu cycle. Boleh juga. Sama. Yang ni dia ambil di bawah loading sampai loading. Sama juga. So ni complete lah ni. So complete. So di mana tempat yang tak bersambung run, lepas tu tak bersambung dengan unload, so situ adalah idle. Ni idle, ni idle, ni idle. So dah ada berapa? 5, 10, 15, 20, 25, 30, 25. 5, 10, 15, 5, 10, 15, 20, 25. Kita dah 25. Satu ni adalah 35, 40. Satu ni adalah 5 lah. 10. 10, 20, 30, 40, 50. 50. So, mesin idle 50. So, mesin interference 50 bagi 90. Satu cycle ni 90. Satu cycle robot ni 90. Daripada sini ke sini 90 satu cycle. So, jadi 50 bagi 90 dapat 56%. So 56% ni tak bagus lah. So maksud dia mesin antara dua mesin ni 56% tak berjalan pun. Idle. So dia menunggu banyak lah. Menunggu. So cara nak selesai dia macam tadi jugalah. So kita kena tengok lah. Mungkin kita lajukan running time dia. Ni running time ni kan. So daripada sini dia tunggu kat sini. Maksud dia loading 2 yang tunggu. Loading 2 yang tunggu maksud dia kita kena percepatkan loading lah. So reducekan ataupun increasekan speed loading 2.
Doktor?
Ya.
Untuk loading, unloading run, robot cycle time, machine idling time, yang tu kita dalam soalan dia bagi Dia orang bagi macam ni ataupun dia bagi dalam ayat?
Table ni akan dia bagi lah.
Dia bagi dalam ayat ataupun dia bagi dalam table?
Dalam table. So, senang lah kan.
Okay. So ni dia dah bagi, then kita just buat dia punya cycle time je lah.
Kita buat chart ni lah. Susun chart ni dengan terbaik yang boleh lah. Janganlah tersilap loading dengan unloading time dia tu. Selalu student tersilap, tercareless ni lah kan. Ni 10, sekejap lagi dia bor 10, silap bor 30, bor 20. Unloading, patutnya run 20 ni. Dia tersilap dia bor unloading 30 time ni. Salah lah. Tapi still ada markah untuk jalan kira lah. Jalan kira, saya punya style, jalan kira ada markah. Tinggi lagi pada jawapan.
Baik, faham betul.
Okay. So soalan ni tak stres sangat pun. Taklah mencabar mana pun. Saatnya. Boleh start lah. Tak memory jam lah dalam ni. Okay. Masa lebih dah. Okay. So ada 3 example lah ni kan. Bolehlah awak try je lah 3 example ni. Bagi saya dah mencukupi.
Satu soalan lagi je lah yang akan masuk exam minggu depan dah.
Dah. Ni bukan. Ni OBE 2 waktu exam, minggu exam.
Oh, ni OB2. Satu ni je.
Selepas raya lah. Selepas ni. Selepas cuti study week tu.
Oh, alright.
Yang OBE 1 ni hari Isnin depan ni kinematik DH. DH tu awak try lah. Awak punya yang awak buat untuk test tu. Lebih kurang macam tu lah. Tapi dia lebih mudah lah sebab saya dah bagi dalam bentuk frame. Jadi awak tak perlulah imagination macam dengan bagi gambar robot. Ni robot dia memang dalam bentuk frame lah. So awak dah boleh agak dah angle dia kan.
Harapnya mudah.
So dia mudah daripada yang test tu lah. Mudah daripada yang test. Sebab dah diberi angle dia semua. Yang penting jangan tinggal kosong lah.
Baik betul, maksud tu.
Jangan tinggal kosong. Sebab markah untuk jalan kira saya bagi tinggi daripada final answer. Sebab final answer normally kalau kata 12 markah ke, so jalan kira is about 8 mark. Final answer about 4 mark, something like that. So, jangan tinggal jalan kira. Jalan kira lagi panjang, lagi boleh dapat banyak markah sikit. Senang saya nak bagi markah. Okay. So hari Isnin. So harap okey lah ni awak tak susah pun. Cuma jangan careless je. Untuk robot WhatsApp ni jangan careless. Careless tak careless, yang penting jalan kira mau ada. So you have high mark on step lah. Solution step. Okay, lagi saya share slide ni. Saya share slide ni. Mana ada folder dia. Lecture note. Robot WhatsApp. Takut lupa. Saya letak je sekejap. Okay, saya dah share dah slide untuk robot WhatsApp.